we now discuss the solution of a problem that has appeared in the CSIR National Eligibility Test in 2023 December examination. And the question is related to the positive definiteness of a given matrix. And this is from the section Linear Algebra, and the question ID is 704032 from section B for 3 marks. This question is suitable for the aspirants of JL, DL, TS set, AP set, IIT JAM and GATE examinations. The given question is for A belongs to R, that means for a real number A sub A suffix A is equal to the 3 by 3 matrix. The first row is 2, minus 1, 0. Second row, minus 1, 2, minus 1. Third row, 0, minus 1, A. Then, which one of the following statements is true? It's a multiple choice question. Only one of the following 3 options is true. Only one is true. We are given 4 options. Option 1, A is positive definite for all A less than 3. Option 2, A is positive definite for all A greater than 3. Option 3, A is positive definite for all A greater than or equal to minus 2. Option 4, A is positive definite only for finitely many values of A. Let's now discuss the solution of the problem in detail. We are given A suffix A given as this 2 by 2 matrix, where the A is given as the 3 by 3 matrix, where A is a real number. Agreed. Now recall the following result. A real matrix capital A is positive definite if and only if it is symmetric. Yes, A is symmetric, and all its leading principal minors are positive. So the leading principal 1 minor, the leading principal 2 minor, the leading principal 3 minor, they are all positive. Let's now discuss further in the next slide. Right. Now we take the matrix AA and study the leading principal minors. So the leading principal 1 minor is 2, which is greater than. AA is a real symmetric matrix, and its leading principal minors are leading principal 1 minor is 2 greater than 0. The leading principal 2 minor is the determinant 2 by 2 determinant 2 minus 1 2, and that is 2 2s are 4 minus 1 3, and the leading principal 3 minor is the whole determinant, the determinant. So 1 minor 2 greater than 0, 2 minor is the determinant of 2 minus 1 2, that is AD minus BC, 4 minus 1 3 greater than 0, and the leading 3 minor is the whole of the 3 determinant, 3 by 3 determinant, 2 minus 1 0 minus 1 2 minus 1 0 minus 1 A. Expanding by means of the first row, we are familiar, the expansion of the determinants. So that will be 2 times 2A minus 1 plus minus into minus 1 plus 1 into minus A, and that is equal to 3A minus 2. This is greater than 0, if A greater than 2 by 3. So all the leading principal minors are positive when A greater than 2 by 3. So AA is positive definite if A is greater than 2 by 3. So all the leading principal minors are positive if A greater than 2 by 3. Therefore, AA is positive definite if A greater than 2 by 3. That is, AA is positive definite for all real numbers A greater than 2 by 3. And that means A belongs to the open interval 2 by 3 to infinity. And if you take a value of A less than 2 by 3, then it is not positive definite. Right. Now let's look at our options. And option 2, AA is positive definite for all A greater than 3. So when for all A greater than 2 by 3, then AA is positive definite for all A greater than 3. Yes, this certainly holds good for all A greater than 3. When it is greater than, when it holds good for A greater than 2 by 3, it is as well holds good for A greater than 3. Therefore, the option 2 is AA is positive definite for all A greater than 3. Therefore, option 2 is true. Now A belongs to the open interval 2 by 3 to infinity. How many A's will be there in that open interval? Infinitely many. The option 4 says AA is positive definite only for finitely many values of A. Therefore, option 4 is false, is not true. Now, I will look at the option 1. AA is positive definite for all A less than 3. A less than 3 includes real numbers less than 2 by 3. Less than 2 by 3. Right. So, for example, you take A is equal to 0. A is equal to 0. So, 0 less than 3. But 0 is not greater than 2 by 3. Therefore, it's not positive definite. Therefore, this is not true. So, also, AA, option 3, AA is positive definite for all A greater than or equal to minus 2. This also, you can take A is equal to 0 again. So, 0 is greater than or equal to minus 2. Right? And 0 is less than 2 by 3. Therefore, it's not positive definite. So, very clearly, options 1, 3 and 4 are not true. Therefore, the answer to this question is option 2. That is the detailed discussion of the solution of the problem, which is related to the positive definiteness of a given matrix from linear algebra. And it is definitely, I say that it is a very easy question. I am sure that you have understood the solution of this problem, and if you like my videos, please like, share and subscribe. I wish you all the best. Thank you.